Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
Hello there.
Hi.
How are you doing?
Yeah, good. How are you?
All good. We're going to do a scalable distributed systems mock interview, correct?
Yes.
And the way that I like to do this is try to mimic as much as possible the real world scenario. So we're going to spend about 45 minutes. I'm going to start first with a quick intro, a couple of minutes. And after that, we're going to do, after the interview, we're going to do feedback where I give you the score. You can ask me any question and maybe share some notes. So one important thing is for me to track your progress in building the spec.
Yes.
And you can share your screen, use any tool that you feel comfortable with.
Sure.
That's pretty much all the preface. Whenever you're ready, we can start.
Yeah, sure. So let me introduce myself. So I have around 14 years of experience developing Java JTE-based applications, and currently I'm working as a full stack developer. And then I'm working on building one product, and one project that is like for Google Finance. So here I'm doing a contracting work. I'm working as a contractor at Google, and I'm working on one tool or application, I can say. It's like it's like like it helps business users to apply the rules on runtime. So this project basically helps the business team to migrate certain data, a lot of data from Oracle system to the SAP system, and then they have to do a lot of conversion, data mapping, so from one system to another system. So for that one, this tool is basically like very helpful to them. So in this tool, they can come and then define the rules. Like if this is the data, then this should be the output. So I I did a lot of work over there in the tool. So I work on both Java side as well as front-end side.
Just to tell you a bit about myself, I'm a software engineer. I currently work at LinkedIn. I've been at LinkedIn for about 9 years, working a bit as a manager and a bit as an engineer. I mostly work on application logging, metrics, analytics, and A/B testing. And before LinkedIn, I was working for many years also as a software engineer in small, medium, large, and startup companies, building from e-commerce applications to financial. We're going to go to the question today. I would like to build a YouTube system. And I'm going to send you a link to a screenshot so we can both see the same thing. It's going to be on the Zoom. I will send you on the Zoom chat a link. To access the Zoom chat, you probably need to go to the menu.
Yeah, sure.
And check the chat. Great. So as you can see, this is a screenshot of YouTube that I took, and it focuses on the comments. So we're going to do that. We're only going to focus on the commenting system of YouTube. So you can assume the videos are already there, and the view video, it's already implemented. We are focusing on building the commenting system. And our objective is to create this screen, the same screen, and the system that powers this screen, right? So just to go over with you, we can see that we have all the comments, right? Starting with a sorting order that we're going to use most recent first, just to simplify. And you can see that we have the total comment count, 6,788 comments. We have, for each comment, we have the author, we have the date, we have a flag if it's edited, and we have the description, the comment body, sorry. And we also have likes, and we have replies, which are also comments, but are folded into a comment that is attached to the video directly, right? So we have these comments that act as replies, and we have the total count of replies per comment.
Yeah.
We can also do comment creation. As you can see at the beginning, add a public comment, and all the comments will become public. And you can also edit the comments and delete the comments as the author of the comment.
Yes.
That's all of the features that we're going to support.
Okay, so let me write it down.
Yeah.
So first thing is like user should be able to create comments. Add, modify, delete comments, right? And the second thing is like for any video, user should be able to view the number of comments. So this, I have one question over here. So this comment is like it could be a tree-like structure, I mean nesting one. So on the count size, so do we need to consider only the parent one, or do we need to consider the child one also?
I'm trying to understand both.
So like, okay. So like here, there is like, these are the replies.
Right.
So when
it will account for both. Yes. Okay. So when it shows both the top level and the secondary responses.
Yeah. Okay, so this is the two main functionalities which I see here. So user should be able to add, modify, delete comment, and the other one should be able to view the total number of count on the comments.
I didn't get it, if that was a question or you were just making a statement.
Yeah, I'm making one statement. Like I'm thinking like these are the two main features. And then if I say like minimum viable product. So these are the two main things which I see, like add, modify, delete comments, and then should be able to view the total number of comments.
I would say that there are two more things that we saw, right? So we saw the liking the comment.
Okay, yeah, sorry. So view the total number of comments, and then like, and then they can dislike also, right? I mean, like dislike the comment. And I would say like voting comment.
And the other one is responding to a comment.
Yeah. Reply to a comment. So from the design perspective, what I think is these are the design constant. So the number of users sending the comment request, and the number of videos that we have, that will also make like also, I mean, that will also be one constant. And from this, I can see. So now, okay, so just want to understand one thing. Um, so when we say add public comment, so this will start a new thread, right? And replying to on existing comment. So that will be like, um, you know, we already have a comment and then we replying on to that one.
Correct.
So the microservice, which I am seeing here is like, I need one service, which is basically, so now in case like if I go and then delete, like I'm the owner, I am the one who created the comment and then I go and then delete the comment. So it should also delete the children comments also, um, or, you know,
Yeah, that's a good question, right? So what do we do in that case? What would you do?
okay, so if, okay, so like I'm the guy who created the public comment and then someone is coming and responding to that one. So ideally, um, it should delete the like the cascading comments also.
Then let's do that.
So here I see like couple of services. Let me write it down. So one service is like for comment service, which will basically take care of the first use case. Another one, the one which I see is like like and dislike service or voting service. So this I'll be and replying to this one. This can also be a part of comment service. Okay. Can I go with the high level? I mean, these are the two services which I see here: comment service and then the voting service. Can I go with the high level design?
Please do.
So this is the client. So I mean, the request will come from. I mean, like if the request is coming for adding the client, oh sorry, comment, then it will come to the comment service, and then if the comment ID is there, then we will get it from this cache. Otherwise, we will. I mean, if it is not there, so which means, I mean, sorry, if it is a read request, then we will try to see in the cache. If it is there in the cache, then we'll get from the cache. Otherwise, we'll go and then see the database. Same thing for the voting service also. I mean, if the comment is already there in the cache, then we'll update the cache also, and then after cache, we can, async in async way we can update to the database, or the other approach could be like update the database and then update the cache. So let me go deeper into the microservice. Some microservice. So here I see like there are 3 tiers. There is the app server here, cache tier, and then storage tier. Now data model for cache could be a key value pair, and here the key will be video ID, and value would be like tree data structure. So it should be like 3 structure kind of thing. So which you can visualize with like comment ID, followed by reply, and this reply could be array, and then this reply can again be so will again be a comment. So um, this is how I visualize the, the comment object. So the comment object will have a comment ID and then the replies. And here you can have another property called like, dislike, and count. Number of replies. And the storage here will be also a key value store, sorry, a key value pair, and the same thing can be reflected. Or actually, like I did the reverse. So this is for storage, and this is for this for cache. So cache will be a key ID pair, and then here I can have a hash map, which is like a video ID. And followed, and it will have a array of comment ID. Or actually, I can have like comment IDs just over here. I mean, this is the whole object of the comment that can be pushed here. And the API REST API. So we need one REST API for create comment. Here we'll have video ID. So in the comment, they can upload image also or just text content.
Text.
I think that should.
Yeah, we'll leave it as text.
Okay. So here, if I pass text content and delete comment, so video ID and comment ID. Then modify comment ID. And for reply, reply to comment, we'll have video ID, comment ID, and the text. So now here, do I need to work on the scale part also? Like just to see like if you need extra storage.
Yeah.
So we need for storage, we need to scale. So like from storage point of view. So I'm assuming like we might be getting like thousands of requests per second. So let me take one number, like we are getting like 5,000 requests. So number of requests or number of comments that we are getting like 5,000 per second. And each comment I'm assuming like is like 200 character max, or what is the max size of the character? Max size that they can enter. So like can I assume like 500 is the max size for character?
I think that's a fair assumption.
So so this many, I mean 5,000 per second we are getting for the comments, and 500 character, and so it seems like there is a lot of load on the server side, on the database server side. So we might need to create shreds for the storage tier. So we definitely need to scale the um, storage. So what I think is like we have 24 into 60 into 365. So number of panels we are getting in 4,000. So definitely I need to, I mean, create um, the shred on the storage side, and so the for sharding you can use like key as video ID and comment ID. And I think this is a write heavy system. So I mean, uh, like, so I mean, we will be getting like this many requests for write.
I think you could do either way, right? So you could consider that the reads are more or the writes are more. Either way is
Yeah.
fine.
Okay. So if I think the reads are more and then the writes are less, so in that case, on the database side, can have master slave, master slave. Um, so master will be used for writing, and the slave will get sync. Um, uh, I mean, like it will be eventual consistent. So so here we can use async process to update the replica. Or instead of this one, we can use consistent hashing also for updating the replica. So now the number of writes are more. So so based on the load, we need to decide like how many nodes will be needed. So if I assume like, yeah, I mean this looks good, master slave, or I mean, do I need to think about like the in terms of like the the column read and write?
Yeah, let's think also about that one to see the difference.
Okay, so in the master slave, there will be one master, and then that will be writing. Service will be writing to that one, and the slave will get eventual consistent. But now, if we try to let me take an example like we are trying to have 5 nodes, and I'm thinking like we write we have to write like minimum 3 nodes, or like 4 nodes, and then the read can be like 2. So if we have 5 nodes, and then the write will go to the 4 1. So eventually every node will get the write data. Or like you can have 3 nodes also here for the write. So the API call should write to the three nodes, three replicas, and then the read can also be. I can make read also be for 3. So when we are reading it, so we can read it from 3 nodes and see they have the consistent value or not. Does it look good?
I think so.
So the quorum write will be 3, and then quorum read will be 3, and then the total replica that we have like 5. Now let me open the throughput. So as we are getting like 5,000 requests for both read and write, and I'm assuming like our server has the QPS of like 500 QPS. So which means we need like 10 nodes to handle the traffic. So let me work on the availability part. So here what I think is like we need the system available, but like um, it can be like a eventual consistent, because this is like not a transaction data. So I mean, if someone is writing comments and then the other guy is saying after some time, so I think that is like that is not going to create a big impact. Is that correct? Or it should be consistent. Like if someone writes now, then they should be able to see it immediately.
No, it's fine to take let's say a second or two.
So I think the system should be available. So it should be like a AP system. I mean, every time we make a call to we go to the video, so we should see the comments. The comments can be eventual consistent, and this need to be um, geographical distributed also. So like um, from other APEC regions, I mean from other regions, different regions they can go and then see the comments. For geo, we need data center in multiple geos. So let me walk on to the voting service. So can I move to the voting service, or do you want me
Yeah,
to cover it?
please do. Yeah.
So in the voting service also, I assume like we need this one here. And we already have this data model over here. And the API, which I think we need is like video. So here we have video ID, comment ID, and likes and dislikes. And the other service that I need is comments. Mhm. And dislike. Oh, sorry for the dislike. We need the same thing. And as this is like not, I mean, here we will not be having so much data. So I think like there is no need for the storage. We don't need to scale the storage here for the voting service because this is just like count. So for every video, we have a very less data here. So we don't need to, I mean, we don't need this storage, the scale, we don't need to scale the storage. So normal storage is good enough. And for the throughput, there is like, um, I mean, this is like not a very compute intense application service. Here we just need to read the video and then comment ID and then the, like there is no computation involved over here. So I think throughput wise, it will also be, I mean, good. So we don't need throughput here. And API, so there will be like multiple calls for the API. Yeah. I mean, there will be like a multiple call for the API, but if we have available system, so I think like here also we don't need to uh, go for the API parallelization also, but the system should be available. Should be a API system and should be accessible. I mean, should be like accessible across the globe. So yeah, we need the key and comment ID, video ID plus comment ID, and then the value will be like just like count. Yeah. So does it look good?
I think so. I think we can switch to feedback now.
Yes, sure.
This is more or less the 45-minute mark, right? More or less. So we cover all the APIs for likes and for comments. I think the APIs look clear to me. One thing that I would say, if I am taking your spot here, is I would also clarify that these APIs will require the user to be authenticated and authorized in the cases of editing, deleting comments, right?
Yeah. Oh, security part.
Yeah, but it's fine because usually you will have that as part of the headers. The other thing that I would also clarify is what type of API is going to be implementing, right? So if we're going to use REST, JSON, things like that. At the beginning of the whole system, I would give it a little bit of time on the decision if I am going to use a pull system or a push system. The one that you're using is a pull system, right? So the
Yeah.
user is making a request to see if there's an update, versus in a push system, the user receives the updates. For example, they are viewing a video, and while
Yes.
they are subscribed to that video, they receive all the comments that are being generated, and also for every other user, right? So so there is that immediacy. Is very similar to a messaging system in that case, right? So you could try either way. I've seen both solutions. Another thing that I would add in the assumptions, I think we hit that a little later, is what is the expected latency of the system, right? So, and we talk about this, and you asked me that question later on in terms of more in terms of consistency. I would make a clear separation between the latency expectation. For example, I make a request, how much it takes to provide a response, as opposed to the consistency, right? So I send an update, how much it takes to be reflected in someone else's next request. So those could be both different numbers, right? So they don't have to be the same. So latency and consistency, assumptions or expectations to set it also at the beginning. Also, I think we talk about the count. I would mention at that point, right? So the consistency of those counts, I would talk about that. Assumptions on the dates, make sure that they are going to be UTC, how we're going to store the content, if it's going to be encoded UTF-8 and things like that, right? So the different ID generators that we are going to use, if we're going to use UUIDs or the database generated IDs, all these I will add that somewhere. But I think the assumptions that you have on the comment size and the number of comments were good. One more assumption that I would do is how many comments are fetched per video and how much comments a video can have. Because that could change things, right? So imagine a video has, like this one, 6,000 comments. We cannot fetch them in one shot. We will need to do a pagination or a paginated API, right? So, and particularly if we have a push system in which there are new updates, you could scroll either forward or backward. So there's going to be bidirectional pagination there.
Yeah, sure.
Great. And for me, I would say the data model is a little bit on the lighter side of things, right? I would expect to have multiple tables here to see the different timestamps, the create type timestamp, update timestamp, deletion timestamp, particularly the update timestamp, because you need to indicate if the comment was edited. the reference to the user that made the comment. Also in the data model, I think the counts, you have them there. The likes and dislikes. And I think that's it. Do I see the relationship? I do not see the relationship between the comment. Oh, yeah, it's there. Comment ID reply object. That one I don't understand really well, right? So from the spec, the relationship between the comment and the response, or the response and the comment, I don't see it like super clear. I see the relationship between video and comment. Oh, I see. It's the first one. It says comment ID and reply object. Yeah, that is confusing. I would have done comment ID to reply ID or comment ID to comment ID, whichever is the model that you want to use. There is also the reply count, right? That I don't know if you want to be computing per each request or you're going to maintain, and also the total count of comments per video. So those are things that you might want to keep them to avoid calculating it again. That's on the data store. I think it was very good that you highlighted what do we do with the comment, the top level comment that is deleted, right? Because it's going to make the reply orphan.
Yeah.
So the other thing that it's going to do, if you have these counts, it will also have to update the counts when we delete the comment.
Yeah.
It's another thing to also take into consideration, right? If you want to be very detail oriented. Estimations on storage, I think it was a little bit on the lighter side of, yeah, we can have a rough estimate on the storage, but do you think that's going to be really important, or is it more important to see things like the bandwidth of
Yeah,
the
bandwidth
system?
is more important. Like,
Right. So I would have focused on that one to see, okay, if we have a throughput of 5,000 comments coming per second, and how many are being read per second, let's say 5 and 5, so 10,000 per second, how much bandwidth that's going to be, and does that fit one node or not in the DB, right? So even if we have replication, it's going to be a primary, and if the primary cannot take enough bandwidth, then we need to start partitioning. So that's the logic that I would have done when you were doing that. I think you did something very similar. You ended up in going to the partitioning, but I would have done it in that way instead of focusing on the storage.
okay.
Other than that, I think that's pretty good. I would have also talked a little bit about the burst. If there is, average is awesome because it's easy to think about it, but usually these things have like a moment where the video is posted, they're going to get all the comments, and then it's going to be pretty much inactive. It's only read happening. So thinking about that process, if you're going to do something about that, right? So, and the dimension, how you're going to size the system based on the possibility of bursts. The other thing is not only burst, but comments that have, or videos, comments that apply to videos that have a lot of activity. Let's say there's going to be a 10-to-1 ratio and the most viewed comments, or maybe even more, like 100-to-1 to the ones that are barely unwatched. So probably that is very dramatic. If you look at YouTube, yeah, you have videos that are like millions of viewers, and then you have videos that have 0 viewers, right? So those are going to have no problem. So how you're going to design the partitioning and replication strategy to cope, to cater those use cases, right? That's it. Well, overall, this was pretty good. Very good structure, very good pace here. Nothing that I would say I would be concerned, right? So we talk about all the different gaps here and there, but those are things that you can adjust. Overall, this was good.
Yeah, sure.
Any question for me?
Yeah, I just wanted to understand. I mean, like on the scaling part, when it comes to the storage and then the throughput, these two parts mainly. These are the main thing. Um, like as you mentioned about the burst and mm, so, I mean, generally, how should I like proceed on that one? I mean, that is the area where I feel little nervous.
I hear you, but I don't really understand the question that you're asking me.
So, like, if the question, I mean, like, if I have to do a calculation, so then what should be the strategy? I mean, what should how to proceed?
Yeah, in general, there is no easy way for me to prescribe,
Okay.
but I would say, in general, try to think about all the different type of constraints, right? So it could be memory that you run out of memory, like RAM, right? Or you
Yeah.
run out of processing power in the node, or you run out of storage capacity in the node,
Yeah.
or you are running out of bandwidth in the network connection. So it could be either of those limitations that you can think of, or it could be
So
that
I
it's
need to.
too much.
Sorry.
Yeah, that's still processing power. Yeah, you were going to ask me something.
So I need to think like from the point of like single point of failure, like which could be a bottleneck and then which could fail. Right?
Yeah, but not so much in this case, right? So we're talking about a single node at this point. So we're assuming this is the node that it's up, but it's not yet failing, right? So when you're talking about primary and secondaries, that will be a fault tolerance
Yeah.
aspect of this. For example, if you say we have primary and secondaries that are being following those updates, right? So what happens when the primary fails? That will be the fault tolerance use case. Or the other case that I can think of is if you have a cache in memory in the app tier, right? So the app nodes, and this maps the user token to a user ID or something like that, or a user account, and that cache just disappears because the server crashes, right? So that could be the fault tolerance scenario that I would analyze for this particular question. But in terms of the constraints, analyzing what's the bottleneck, I will look at those different factors, the four factors. Do I run out of time with processing power, space on the disk, um, RAM on the memory, or is it that I'm running out of bandwidth in the network capabilities, right? And you have to consider then inputs and outputs.
Yeah. Sure.
Any other question? Any other thing that you're thinking?
No, just wanted to get some suggestion and then. So I mean now in terms of like I mean you provided your suggestion for this storage and the need for scale. So geo distribution will come into picture only when we have the users across the globe, right? So
Right, and also when it's bandwidth, latency are really important if you factor the distance, because if you're talking about crossing the globe, right,
yeah,
to deliver content, crossing the globe and adds latency, and that's where you will think, okay, there is a geo component, right? Or if you have multiple data centers in, let's say, in US, you have a different coast where you want users to have more locality of their data instead of replicating everything across the whole system. So there are solutions that are geo-based.
no,
And yeah, I've heard of such systems. In this case, I didn't add that.
yeah. So in this case also we need like geo distribution thing, right? So user can comment from
Yeah,
anywhere.
depending on what you want to do and what's the numbers that you're seeing, right?
Yeah, sure.
Because if the expectation is, let's say, 1 second for the response, you can even cross America and it's fine. It won't be fine for the globe because definitely you will have to have a replication strategy that somehow drops data in different parts of the world, ensuring that it's less sub-second anywhere in the world. Right? Now, there is also the last mile, the provider, in which you cannot do anything, right?
Yeah.
So that will be an assumption that I would use if someone wants to go with that geo approach. In any case, thank you for being here today. I will send you the feedback here and wish you good luck in the practice.
Thank you.
You're very welcome. Bye-bye.
Bye.